joining now. That's fantastic. So everyone who has just joined, welcome to this evening's meetup again. We have quite an interesting topic and quite an interesting guest as well. With Donald Martin, who is joining us from the US today, who is spending his early morning hours basically to join us here. So fantastic that we have a time zone sometimes. That's pretty good, isn't it? And we have Andrea Deinert from SAS, who also joins us, who is going to lead us a little bit through the beginning time here. So thanks both of you for joining us today. So what will be our topic, Donald, today? What are you going to tell us?
Well, today I'm going to talk about updating the traditional product development process to achieve more fair machine learning, and particularly updating it so that it's more participatory and that it involves communities more in the early stages of product development for machine learning and AI-based products.
Ah, cool stuff. Sounds pretty interesting. So for everybody who has just joined, just a few rules on how that all works here. If you look at the navigation bar of what you find beyond, you will see there's a section, there's a special icon which you can press to start the question part. So if you have questions, just ask your questions. These I'm trying to follow up on your questions, and I will ask Donald during the presentation so that he can focus on presenting and me just looking for your questions. And so chat is usually not used for the questions, but please just join the question and answer section. Andrea, I would like to pass it on to you.
Thank you. Now it's my part to ask you some question as an introductory. So let's start with a very basic question. Why is bias a subject of interest for you? What do you think? What would you answer on that? What are your experiences in this regard, and what are your thoughts about it?
So one of the main reasons that bias is that I'm focusing on bias at Google really has to do with like a desire to help as many people as possible understand the underlying systems and structures that lead to some things that we're seeing in the world today. For example, the disproportionate impact of COVID-19 on African Americans, as well as Black people in Britain, for example. So that has to do with underlying systems and structures, and those underlying systems and structures are the source of bias. So that's why I'm interested in this topic of bias, because if you want to understand those structures, you have to understand bias because it's a component of those.
And do you have personal experiences on the bias in connection with algorithms, or is it just an interest which flew to you at some day in the past?
So I'm sure that I've been impacted by algorithmic bias in some way or fashion, like applying for a credit card or a loan. I'm sure I've been impacted. But really my interest is in understanding and solving societal problems. And so that's really what kind of brings me to the space. And we talk about machine learning and AI. Those things exist because of training data. That's the key fuel for that. But all that data is generated by society. And it's generated by people's perspectives, usually people trying to understand or solve some sort of problem. Societal problems are a big part of that. And so if you're interested in pursuing ethical AI or machine learning fairness, eventually you have to get back to like what's generating the unfairness, what's generating the data that drives the algorithms. And so that's how I ended up working on machine learning fairness and ethical AI. I didn't start there. I started with like, how can we understand these complex societal problems better? And then I got exposed to the fact that in the ML fairness community and in the ethical AI, in the technology community, this focus on ethical AI has that same requirement of understanding the underlying societal context. You can't solve those problems without having that common understanding.
So do you see the future positive for those societal context, or how would you judge these things which are lying in the future for us as a society, as the entire society?
Well, I think it's a interesting time. It's a dangerous time. One, because the technology is advancing so rapidly, and we don't yet have the ability that we need to be able to kind of predict and anticipate the impacts of these technologies. So there's that aspect of it, but it's also like a hopeful time as well, because the technologies, particularly AI, has become like this super powerful mirror on society. And it just makes it very obvious, right, that we have to tackle understanding the underlying societal context in order to be able to build, safe, useful products that don't discriminate, that don't harm people. So it's a time with risks, but it's also a time with opportunities. If we can kind of seize on that opportunity and really focus on the underlying root causes of what are generating, some of the harmful outcomes that we see with the technologies.
It sounds very interesting, and I'm really looking forward to your talk now. And yeah, thank you very much that you answered my few questions.
My pleasure. My pleasure.
So thanks, Donald. If you like, you can share your screen now. Again, welcome everybody who is just joining us to the AI Suisse meetup, sponsored by SAS. I have two people here. I have Donald Martin, who is actually talking for us, presenting the stuff. Really looking forward to his speech. And Andrea Deinert, who just did the introductory questions. So thanks for all joining us.
Okay, so let me just get 1 second.
Sure. That looks like a presentation. Fantastic.
Yeah, let me just present it here.
One technical question, administrative question. Will the presentation be available afterwards?
So we have the paper available, and we actually have a version of this talk that's available. So I can make that available, like a summary of it.
Yep.
And so there are a version of this that are out there, not necessarily this specific version.
Okay, cool.
Yeah.
Thanks.
So let me know when you want me to take it away. Should I go ahead and start?
Yep.
Okay, cool. So as I said in the beginning, I'm going to be talking about upgrading the product development process to foster machine learning, fairness, and ethical AI. And let me make sure I can actually, there we go. Yeah, that's working. And so there's 4 key points that I want to try to get across. One is that we tend to focus on training data and model architecture and performance when we try to mitigate unfair bias, but this tends to abstract away upstream sources of harmful bias. And in this talk, I'm going to be proposing that the traditional product development process should be updated to include an explicit formal problem understanding and formulation sub-process. And problem understanding and formulation is further upstream in the typical technology or product development lifecycle. This is even before you design anything. And this new sub-process, we're going to try to make the point that it needs to be aware of the societal systems and structures that generate the problems that we want to understand, the problems that we eventually want to solve. And because of that need, and because these societal systems and structures are what we would call dynamically complex, we've been focusing on the possibility of leveraging an approach called community-based system dynamics, because we think it's a promising approach for actually operationalizing this new problem understanding and formulation sub-process. So I want to start with this quote from a 2017 AI Now report that says, producing technologies that work within complex social realities and existing systems requires understanding social, legal, and ethical contexts. Now, this required understanding is really hard to come by because we're talking about society as a whole. It's complex, it's dynamic. And so folks in the ML fairness and ethical AI community realize that this understanding is required, but we don't really have solutions for gaining that understanding yet. And when we don't have this understanding, it leads to this recently discovered racially biased medical algorithm that's based in the US and it's widely used throughout the US.
Donald, just a quick question. If you talk about societies, are we talking about Western societies, or do you have a more cultural diverse thing in mind?
We're talking about society as a whole, right? We definitely, so when we're trying to get this societal understanding, it needs to be global. It needs to include all cultures, all different, individual societies, micro societies, I guess you could call them.
Interesting. Okay.
Yeah. And so this particular algorithm, the system that it was part of had the goal of identifying patients with the most complex healthcare needs so that they could be given access to special programs. And the idea is that this would reduce the cost in the overall US healthcare system. But people that were not selected for these special programs by the algorithm actually suffer from nearly 50,000 more chronic diseases than the people that were selected. So the algorithm was selecting the wrong people. And the people that were not selected were disproportionately Black in the US. And so this is why it was deemed to be racially biased. So the question is what happened? Why did this occur? And the researchers who studied the algorithm and how it was created, they identified that the root cause of the failure was the target variable selection decision that takes place during problem formulation. So let's take a look at the end-to-end product development process to see where this sort of decision takes place. So this diagram depicts, a typical product or tool development process. This is particular one focuses on ML as an element of the system that's being designed. And we typically focus on that middle section, that middle gray section that's called ML system design and development. When we think about how we're going to mitigate their bias, we focus on like what data sets are going to be selected. We focus on how we're going to choose the right architecture. We focus on how we're going to evaluate the model as we're training it in terms of bias. But for the case that we just talked about, the bias actually originated during that blue phase, further upstream, problem understanding and formulation. This is where that target variable decision was made and where some other key decisions impacted that. So those are high stakes decisions. And so I want to drill into that for a second. So the sorts of decisions we're talking about is even what are our goals and strategies as an organization that impacts this target variable selection? What problems should we solve? What are the relevant factors? That's a super critical decision, choosing those factors. Who are the target users? Who do we think we're delivering this technology to? And what are their needs? And so these decisions are high stakes. So let's just talk about how humans make decisions for a second. This is some research from Zhang and Marsh that says causality is inherently linked to decision making, as causes let us better predict the future so we can intervene to change it. And so when we make decisions, we're leveraging our causal inference capabilities that we have as humans. And this is a quote from another piece of research from Tenenbaum and Griffiths that says, people routinely make sophisticated causal inferences that are shaped by strong top-down prior knowledge in the form of intuitive theories. Now, in the work that we've done, the papers we've written, we refer to these intuitive theories as causal theories because of their linkage to causality, as I just talked about a second ago. So let's take a look at what role these causal theories played in the particular case that we identified where we had this racially biased algorithm. So just to recap, the problem was to select patients with the most complex healthcare needs for special programs. And the designers, engineers, they made the causal assumption that patients with the most complex healthcare needs would spend more money on healthcare. So if you had more complex healthcare needs, you would spend more money on healthcare. This is with the causal theory that they utilized. And this led to spending on healthcare being chosen as the target variable for the algorithm. Now we know that this algorithm failed, it had this failure. But why was it problematic? And the primary reason is because this causal theory leaves out many critical factors that influence how much people in the Black community spend on healthcare. So an additional problem is that when this causal theory was formulated, when it was formed, no one from the Black community was represented, in the room to formulate this causal theory. It's often kind of implicit. It's not made explicit for other people to critique and criticize. And so if that happened, these key factors, it's likely that they would have been raised as part of the big picture, because underdiagnosis due to bias in the US healthcare system actually decreases how much people spend on healthcare independent of what their healthcare needs are. And the same is true with the lack of trust in the healthcare system, same is true with wealth and income disparities, same is true with the lack of access to affordable healthcare. Now, these factors make up a subset of the healthcare system structural inequities that exist in the US. And these structural inequities also lead to increased complex healthcare needs in the African American Black community. And this has been borne out by COVID-19, because these structural inequities have actually led to Black people disproportionately dying from COVID-19. They actually contribute directly to that. So you see that this is quite a more complete causal theory, right? Because it adds these key factors that not only decrease how much a particular community spends on healthcare, but also increase how much complex healthcare needs they actually have. So this explains why the algorithm ended up being racially biased, because it did not consider the complete story, right? The causal theory was incomplete and it led to a problematic proxy choice. Now,
can I just quickly ask you a question again here?
Yes.
Regarding the data set, actually. So many things come to my mind. One thing is, I would usually say we need some data before we decide that there's a causal relationship between complex healthcare needs and spending on healthcare, but might be backed up by market research, for example. And you usually, if you do market research, you segment the classes you're asking the people to set, and usually might come up with some factors which contribute to decision making here, which are racial. So is it just something like this relationship, which was a gut feeling? So someone decided that might be a relationship, but it was not backed up by data?
Yeah, so interesting thing here. So two things. So for those factors, there is a mountain of research that back up all of these factors. But one of the important things is that during these early stages, we don't want to limit leveraging. Here's a reality. We leverage our intuition when we're making these decisions, period, right? And what we don't want to do is totally tamp that down, but we want to make sure we're not relying on just the intuitive theories of like a small group, right, that doesn't have lived experiences with other parts of the system. So it's important. So I'm pointing out that there is concrete data associated with those factors, but I also don't want to contribute to the idea that you have to have data a priority to start to write down your theories about what the causal relationships are, and to work with people to understand what their causal theories are. Because oftentimes, if we just start with the data that we have, we don't identify data that we should have. And so this is kind of like a big problem, right? If we just start with, we're going to understand this problem based on data that's already been gathered as our only source, it's going to limit the scope of what we look at. And so it's really important to kind of include people who have lived experiences, who may not be a PhD or written a paper, but they have some ground truth about the impacts of structural inequities when you're trying to get healthcare in the US, for example.
Okay.
Does that answer your question?
Yeah, I still have more questions.
Okay, cool.
Yeah, I mean, the natural thing is you can model, or you can do some factor engineering, right? To see if you just have a data set and you're preparing that and see how an algorithm reacts to the system, and we find out that for some reason more white people actually really do spend more on healthcare. Of course, the next question would be what's happening with the rest of the people? What do they do? and why do we do different? So pattern recognition or something like that of that kind of different behaviors would be interesting.
Yeah, and the interesting thing in this case is that the researchers, like they discovered this way after the fact, after this was built. They weren't even looking for this racial bias,
Yeah.
and they ended up discovering it, right? And so these are folks that have access to all the data, right? The people built it had access to all the data, but this was never discovered, right? And so if you had in the beginning when you're trying to understand the problem, even before you have all the data sets, if you were just to involve experts, people with expertise,
Yeah.
right? You would at least develop a better hypothesis about like what's the underlying structure and what the factors are. It doesn't mean it's exactly right or true, but it points you in the right direction in terms of like what data sets should I be investigating? What additional research should I be looking for? And that's something that's a step that's often missed in the early stages.
I think it's a good point that you mentioned human factor here. So human experts. So I would say that people from the Black community in this case who have a better understanding of their attitude towards the healthcare systems, the problems involved with that, would have been the better experts than data to say, hey, we might have an issue here, and we need to take care of that because it's a completely different attitude towards the healthcare system.
Right, exactly. So we have to kind of rethink our definition of expertise.
Yes.
What is an expert? What is knowledge, right? What is authoritative knowledge?
Yeah.
We have to rethink that a little bit, particularly in these early stages, so we can kind of learn from the lived experiences of people that really have ground truth and knowledge.
Yeah.
So we have to kind of be able to consider the expertise on the same par, at the same level as having expertise in doing factor engineering, right, and data science, right?
Yeah.
Who are people who have expertise about what the factors might be.
Mm-hmm.
So this sort of diagram is like oversimplified and highly linear. The reality is this collection of causal theories and these factors. When we talk about societal context, this is what we're talking about, right? This is like the core aspect of societal context is what are the causal theories that people have in their heads that drive how they behave in society and basically how they create society. And so a key aspect is if we want to kind of tackle this problem of creating more complete causal theories, we have to tackle that. We're trying to understand societal context, and societal context is a dynamically complex system. It's constantly changing non-linearly due to inherent time delays and feedback loops between elements. And so as we think about tackling this, we have to take that into consideration and think about what tools and practices we would need for that. And so we thought about, so how would we tackle this problem of incomplete causal theories that lead to problematic proxy choices? And our recommended approach was to introduce a formal and explicit problem understanding and formulation sub-process to the traditional product development process. Because right now, problem understanding and formulation is very ad hoc. There's no formal process for it. It's not explicit. And so it's hard to kind of document and add methodology and process there. But this is such a high stakes aspect of the process that we think it needs to be made more formalized and to be made more explicit. And in particular, it needs to be optimized to do three key things. One, it needs to be optimized for collaboration happening during that causal theory formation. So if you just have a few people forming their causal theories and that driving the process, then you're going to have a problem, right? It needs to be done in a collaborative way in partnership with the communities that are typically most negatively impacted. It's not hard to identify those folks, right? When you see the problems with algorithmic bias, it's typically impacting marginalized groups by gender or sexual orientation or by ethnicity. So this causal theory formation step needs to be done in a collaborative way. It needs to center the lived experiences of the marginalized communities that are most vulnerable to things going wrong, right? They're the ones that are marginalized in society, and so the data generated by society is going to include biases against those groups. And then finally, it needs to be able to contend with this dynamically complex nature of societal context that I was just talking about. So new sub-process, in order to operationalize it, we need to make sure we can handle all these aspects. And so the idea is that we will end up with this new subprocess inserted in between institutional prioritization and funding and product conception and design. That's all about problem understanding and formulation. The problems usually arise when you're talking about prioritization and funding. The next step is to like really deeply understand the problems. And when you start to ask, when we insert this, you'll start to ask different questions. You'll start to ask about like, not what problem are we trying to solve, what problems are we trying to solve, and what's the problem domain? You start to ask, what is our dynamic hypothesis of that problem causal structure? Because those causal theories, they're hypotheses, they're not correct. But we have to take a shot at it because we are leveraging them, whether we realize it or not, to make key decisions. And then we'll ask, like, what are the peripheral stakeholders that we should work with that we might not have thought of if we weren't thinking in this mode? And this will lead to us asking different questions when we get to the product and conception design stage. We'll start to ask, like, what's the best way for us to intervene on that problem structure, as opposed to, we should use machine learning for this, or we should build a product with these features. We'll actually ask, is a product feature really the right way to intervene on this structure? Is machine learning really the right thing to use to intervene on this structure? And those are sort of questions we want to ask very early on. Now, we have...
Can I just go back once?
Yeah.
You said something like societal context, and we need a kind of version for different cultures, something like that. So looking at the process you're describing here and you sketched here, thinking about the team size of the product development process, I'm just thinking about how can that work? If you think of minorities, minority communities, or as I said, thinking about communities with highest negative impact. So do we really have the knowledge to know that? And so there will probably always be minorities where we just have of lack of competence, lack of knowledge, any clue of idea what problems they really have. So what team size are we talking here, and what kind of expertise do we need to have?
Yeah, I'm gonna talk about that a little bit further.
Okay.
Because some of the work that let me talk about that at the end. I'll talk about what our next steps are going to be. Those are great questions. But one thing before I go past this, I do want to make sure I understand you. When you were talking about lack of knowledge and competency, were you talking about where were you talking about that?
Yeah. So if I think about a typical product development team size, so
yeah.
2 to 5 people, for example, and I think I'm a very open person, so I'm looking for the problems of other people. That's fine, but I guarantee I have no idea of everyone's problems. And thinking about, one thing, like I once heard that in New York there are 800 languages in the city, 800 languages, which is crazy. Yes, this is like that's a huge translation program.
Yeah. Okay. Yeah, I got your question. So just to give you a short answer. So we cannot solve this problem by we need to have more diverse teams. That's definitely that is a key problem within machine learning and ethical AI.
Yeah.
But we won't solve the problem I'm talking about by just trying to build more diverse product development teams, because it's impossible to have a team that's diverse enough, as you're saying, to understand all the languages and problems. So this is about building muscle within these organizations to collaborate externally, right? Building the capability and the time to actually work externally and partner externally with groups that already have expertise in working with communities, right? Who already have the relationships, right? Who speak the languages, right? Building that muscle and building that time to we have to build relationships with community. It's not optional anymore. And we have to build relationships with people that have relationships with community so that we can scale this, right? Because you won't be able to scale it just within individual organizations.
Yeah, sure. Makes sense.
And so to kind of get a little bit to the scaling aspect, so we've been focusing on something called community-based system dynamics as a way to operationalize this new sub-process. And system dynamics was invented about 60 years ago at MIT, and it was invented specifically to help people understand complex, really human problems that were generated from human needs. And community-based system dynamics is a particular variant of that that is focused on centering communities in analyzing problems and building capacity within those communities to use system dynamics to explain, for communities to describe and explain their problems themselves. And then that kind of sets up the ability to have conversations, right, with product teams who hopefully speak the same language so they can start to communicate about like, all right, what is the structure of this problem? So there's capacity building that needs to happen in the communities, and there's capacity building that needs to happen within the technology companies. And I think the capacity that needs to be built is for those communities to be able to speak a common language, to talk about problems in open, transparent ways, and to describe and to come up with shared hypotheses and theories about what the structures are that are generating problems. And CBSD in particular is a participatory practice for including communities in this process of developing a shared understanding of complex problems from the dynamic feedback perspective. And remember, I was talking about societal context is dynamically complex and there are feedback loops. So SD is optimized for that. CBSD is optimized for empowering communities to do that kind of work. And then CBSD leverages visual tools and simulation to support groups in the co-development of these explicit and transparent causal theories. And so I'm going to just do a little brief overview of what these visual tools are. It really starts off with a qualitative representation of the dynamic hypothesis of what the causal structure is. There's two representations. One is called a causal loop diagram representation. That's a CLD. And remember, we talked about how causality is core to decision making, which is why we need to leverage a technique that embraces this idea of causality. So I'm just going to walk through the elements of what one of these diagrams are. On the CLD representation, it's really talking about a system about loans and about how people get loans. And key elements of these diagrams, number one is the causal factors. So in this case, causal factors are things like average credit score, loan defaults, payments made. And then there are causal links between those factors. Those are the lines with the arrows. And those lines with the arrows, they have a particular notation that lets you represent a couple things. Lets you represent the monotonic effect of one factor on another. Does it have an increasing effect or a decreasing effect? And then also lets you represent whether there's a time delay from the time that one factor will have an effect on another. And that's represented by the hashtag. So let me just walk through an example. So in this system, it says that as average credit scores increase, that will lead to more loans being received. That's why there's a plus sign next to the loans being received. Also, another example is if there are loan defaults, as loan defaults increase, that will decrease the average credit score in the system, right? So that monotonic effect is a decreasing effect. Now, the other key element of a causal diagram are these feedback loops that are kind of super important to understand. That's why these diagrams are cyclic. They're not acyclic, which are some of the techniques that are used to represent causality in the machine learning, fairness, and ethical AI world. This is work that's led by Judea Pearl's approach to representing causality, structural causal modeling. Those are acyclic diagrams, which means that you have to do special things to capture the cyclic nature. And that cyclic nature is super important if you're trying to understand societal issues and human-driven problems. So there's two types of feedback loops. Feedback loop can either be balancing or reinforcing. A balancing loop is something that balances out a growth phenomenon for a particular system. It's not just growth, right? It balances out like something that is either accelerating, growing, or decreasing, right, rapidly. And this balances that effect in one way or another. So in this case, we have the situation where you could have this virtuous cycle, right, where you start off with people receiving loans, Then you have the borrowers, and those borrowers, as the borrowers increase because they receive loans, they make their payments on time, their credit score goes up, more loans are received, more borrowers, more payments, right? This virtuous cycle. But that gets balanced out by this balancing loop of the fact that some people are going to default in their loans, right? So this balancing loop is, all right, people had their credit scores led to them receiving loans, that leads to more borrowers, but some of those borrowers are going to default, right? Which is going to decrease the credit scores, which is going to decrease how many loans get received. So this balances out this potential of like having this exponential growth in the number of people that have loans. Reinforcing loops have the opposite effect, right? They kind of contribute to this exponential growth. So in this case, the reinforcing loop is people making their payments, right? So borrowers get their loans, and as people are making their payments, this is going to reinforce this overall cycle because credit scores are going to go up because payments are made. So it has this impact of like continuing that cycle of the growth in the number of loans that are being received. So those are the key elements of these causal loop diagram representations. And this is typically what you start with, right? This is called a qualitative representation. You don't need to have a data set, figured out in order to do that. You're really trying to get a shared understanding of people's causal intuition about what are the relevant factors. And they bring to that intuition comes from their experience and their expertise. That expertise may be a PhD in XYZ, or that expertise may be lived experience with getting denied a loan or receiving a loan. The next representation is called a stock and flow representation, and you can represent all those same elements, right? You can see that all those factors are represented here. They're just represented in a slightly different notation, the stock and flow notation, which allows you to start to quantify those factors and be able to quantify how those factors grow and decline over time. And so this is where you can start to represent the differential equations aspect of these. And this really sets you up to be able to simulate your dynamic hypothesis. And this is where you can start to add, real data that you have, historical data. And you want to do that because you want to validate your hypothesis. You want to see if my hypothesis about the structure, can it generate the historical data that we already know about how the system performed? And then that gives you more confidence that you understand the structure. And then when you have more confidence in it, you can start to plan your interventions on that structure. Because the way you will have that structure produce a new behavior is by somehow, adding a new feedback loop, right? For example, somehow intervening so that you can shift what that structure generates. Now I'm gonna. Did you have a question, Stefan?
No. Can you use the mouse if you explain the chart?
Is there there's, we talked about the average credit score as being a key factor. Average credit score, as that increases, the number of loans received is going to increase.
Yes.
And we express that with this monotonic effect.
Yes.
We have this indication of time delays, right, with this hashtag. So we have this factor of payments being made, which will lead to credit scores going up, but it won't happen instantaneously, right? There'll be a time delay. I have to make my payments, on time for a year or two before it's going to impact my credit score.
Yeah. Wow. Okay.
Yeah.
So the B is standing for balancing, right? And
the B stands for balancing feedback loop, and it balances out like this kind of exponential growth or decline that could be represented. In this case, it's a growth, right? More higher credit score, more loans, more borrowers, more payments, higher credit score, more loans, right? This kind of virtuous cycle, right? It could be a vicious cycle if it's something that you don't like, right? If maybe the number of loans being given out is going down really fast, right? That could be a vicious cycle. Balancing loop balances out that effect, whether it's a growth effect or a decline effect. Right? And then a reinforcing loop reinforces whatever the kind of tendency of that system is. It reinforces it as opposed to balancing it.
Got it.
Okay. Now, so the next thing I'm going to do, and this will be getting close to the end, I'm just going to talk about like some work that we've actually done to build capacity for people to be able to think about societal problems using these techniques. And I talked about how important it is for communities to have capacity to do this. And so when I first started this work, I started explicitly seeing what would it take to build that capacity in communities. And my target was to basically introduce this to a conference that's called the Data for Black Lives Conference that was started about 3 years ago in the US. And this is a collection of data scientists and machine learning experts and policymakers who are really interested and concerned about how data can amplify biases. It can also be used for good, but how do we get together to work on how does data impact Black lives? And so I wanted to introduce this technique there. But first, I wanted to make sure that I trained people on this technique that actually had similar lived experiences to the people we were gonna teach it to. We wanted to make sure that they could relate to those folks. So we had to teach them. So the first thing we did a learning lab to teach people about community-based system dynamics. And this is a picture from that learning lab. And these are people from a combination of Google and people that the Data for Black Lives community told us would be good candidates to participate. And so this is what it looks like when people are putting their hypotheses and their causal theories down on paper, and then you can actually represent this in software as well, because eventually that'll allow you to start to simulate these things and add data and do kind of deep analysis of them. So these are folks kind of learning how to utilize these techniques. And then those folks that learned in the learning lab, they actually taught a 70-person introduction to community-based system dynamics at the Data for Black Lives conference in January 2019. So this is them teaching this group about causal loop diagrams, very similar to what we were just going over, and balancing loops and reinforcing loops. And this is what it looks like when you get a group of people together to do a group model building exercise, for them to start to collaborate to come up with a shared hypothesis and theory about what are the relevant factors for a given problem. I think in this case, we were talking about wealth and income disparities. So this is just to give you an idea of what that looks like and some of the artifacts that are generating, right? So this doesn't look pretty in the beginning, right? But people are collaborating to express together and learn from each other what could be relevant factors for a given problem. And then once you kind of gain some shared understanding here, then you can migrate this into software if that's the right next step. Sometimes these first steps are enough for you to learn a whole lot that you didn't understand, and to learn like, hey, we should be gathering data about this particular factor. We didn't even think about it, for example. Just another look at some of these artifacts. And then this last slide, I just want to get across that, there's no, a priori requirement of being an engineer or a system dynamicist, right, or an expert in math to be able to learn these techniques. This is actually my wife, who does a lot of work on racial justice. And she, in a 2.5-hour session, she was able to start to leverage this to help her think through some of her racial justice programs and what the problems are and what factors she needs to make sure that she includes in order to make sure that what she's trying to do will scale. And so the main point is that, these techniques are learnable in a short amount of time, at least for the beginning process, the qualitative diagrams. It does take a lot more effort to learn how to do simulations and add data and do sensitivity analysis. That's another end of the spectrum. But the idea is that it sets you up well to be able to bridge the gap between the qualitative world, where many people can participate and add their knowledge and expertise, and then you can bridge the gap to the quantitative world through those stock and flow diagrams, where you start to leverage more deep data science understanding and mathematical understanding. And we want to have those two worlds to be able to communicate. And that's kind of what's good about this technique. So I'll just close with kind of what our next steps are, what we think the next steps are to try to actually realize this, because we're in the very early stages. And so we're in the stage where we've published a couple of papers that have kind of laid out theory for this.
Sorry to interrupt you.
Yeah.
If can you just go back to the last slide again? Sorry.
Yeah.
So Tonya, that's your wife, right?
Yeah.
So you talked about learning labs. What is a learning lab? Is it just a place where you learn those techniques, or what is it?
Yeah, the learning lab was something that we created in order to basically teach teachers. We wanted to teach people. We wanted to not only, typically you'll do a group model building exercise for people to work on a specific problem.
Yeah.
The learning lab was for people who didn't have any exposure to system dynamics, for them to learn the basics of system dynamics so they could teach the basics to someone else.
Ah, yeah, okay.
Yeah.
And the Data for Black Lives, what is it? Is it something where you're involved with? Did you found it, or how do you work with it?
Yeah, I didn't found it. It was found by a woman named Yeshi Milner.
Yes.
You can find it on it's d4bl.org. It's an important organization to know about. And as soon as I found out about them, I was like, oh, this is the first place that I want to start to introduce this idea. Because if we aren't able to build capacity in these communities, then the idea won't scale. It won't have the effects that we want. So I kind of worked with Yeshi, the founder, to said, hey, I would like to do this at your conference, and here's why, because I think it's an important part of data science to really be able to understand the problems before you try to solve them with data science. And so she agreed to give us space there. And then so we had to basically teach some teachers so that they could teach a workshop there.
Interesting. So if you do such kind of work in the learning labs and with Data for Black Lives movement, do you use it at Google? Is it something which you just use in doing machine learning there, or is it just something which is a side project for you?
So it's not a side project. This is what I work on full time. And so remember I was talking about we need to build capacity to collaborate outside of our core organization. So that's why we did this work with Data for Black Lives, because we need to build relationships with these organizations. We need to build capacity for us to be able to speak the same language. And so I'm also within Google doing the same sort of work to build capacity, doing learning labs for people to learn community-based system dynamics, because we want to have, the two groups to have a common lingua franca, where we want them both to know what a causal loop diagram is. We want them both to know what a balancing feedback loop is, what a time delay is, so that they can work together to develop these causal theories and represent them using system dynamics.
Awesome. Well, I have two questions from the community already. I would like to wait until the end here.
There's just one more slide, and then we can take the questions.
Okay, thank you. Okay.
Yeah.
Aiken, you're just part of it. Let's just wait a little bit, okay?
Yes.
Thank you. Okay. Yeah. So just to close, so our next steps, I was alluding to this a little bit. So we've got a lot of work to do to actually test the efficacy of doing this kind of work within product development in tech companies, right? We're in the very beginning of that. And so a key thing is we have to identify the constraints of trying to practice this in corporate environments. Yes. And in partnership with communities, right? These are new types of capabilities and muscles that we have to build that we don't necessarily have yet. And of course, we have to realize that these corporate environments have existed for a long time, and they have existing cultures, they have existing incentive structures, right? We have to understand what they are and build new ones to encourage people to actually develop these capabilities and partner with communities in these early stages of product development. And then finally, we have to make sure we're building capacity within communities to fully participate and lead. And as I said, that's the first thing that I started with by partnering with Data for Black Lives. And so I'll close with that. And I think that just the last thing to emphasize is that we need to kind of move from a problem solving first orientation to a problem understanding orientation. And then we have to make sure that we are valuing expertise that we would not typically label as expertise. Lived experience with these problems, in addition to expertise on specific societal problems, expertise in computing, expertise in machine learning. We need to combine all those expertise and think of them as being on the same level. Okay, so I'll close there and then we can go to questions.
Just a practical question. So since you're teaching that kind of using system dynamics in that context, is it something you would like to roll out internationally? So we have international people participating. Is it something we can actually learn from you?
Yeah, I mean, you can learn it from anybody. You can also learn it from the system dynamics industry. There's actually a organization called the System Dynamics Society. They do an international conference. They just had one 2 weeks ago. And so the people I work with are like key participants in that society. And so you can go directly there and you can, look at resources, take classes. Yeah, so there's multiple ways. And so I'm not going to be taking on like teaching the whole world, but I do want to expose folks to the resources that are already available. And I think there may be some unique things that we learn about what it takes to adapt this for corporate environments. And so once we get those sorts of learnings, those are things that I expect that we'll be talking about more externally.
Thank you. So as I said, we have upcoming questions already. So I put Yaroslav and Ekin here on the panel as well. Yaroslav, would you start with your question first? Can you turn on your audio so we can hear you?
So I'll stop sharing my screen now.
Yeah, that would be good. I think it's fine. Yeah. We can even come back to one of presentations. Yaroslav.
Yeah, I'm sorry. My question maybe has already changed a little bit since I asked it. Basically, initially it was related to the problem of this study related to risk assessment for black and white patients. My question initially was whether any study of existing state of art in healthcare research had been made, and if and now my feeling is that the problem is that maybe in commercial environment there is simply no people to study the previous study on the topic, and in this case there was still there might be there was maybe nobody who would check what indicators are good or bad for healthcare treatment. Is finally the problem is that commercial on commercial side we simply not able to track the right indicator and we are not able to check what had already been done on the subject.
Yeah, I mean, I would say, if I understand your question, I would say, so there's ability, and then there's kind of will, right? So I think you need a combination of both. So there is like a need for developing kind of capabilities to partner in an interdisciplinary way with people who do have that knowledge. But that won't happen unless there's a will to say, oh, this is actually important. It's a top priority for us to build that kind of capability and those relationships, and to build in points within the product development process, gates, that you can't go past that gate unless you have done, some work to develop some sort of hypothesis about what those causal structures were or are, and that you can indicate that, you worked with some community experts, right? And some experts in that domain. So I think it's a combination of will and capability, and the capability won't come without the will.
Thank you. Ekin, you had some more questions as well. You're a social scientist, as you mentioned. What are your questions?
Yes, first of all, thanks for the perspectives and knowledge. I'm also doing a little bit of research on diversity in management. So I'm a management scientist. I don't know if we can call that. But so yeah, I mean, this is great. The causal theories, that's very interesting and very important, especially designing these AI systems that are coming into organizations and affecting everybody all the time. But I had like these kind of a little bit higher level, maybe questions that we often have to tackle. And I'm just curious hearing about your opinion, and I'll just read them out. One is, some people argue that causal theories are never complete, especially when we're talking about social science. Maybe for physics, even there we don't have really completeness yet. But if I mean, this doesn't mean that we should just give up and not pursue, right? But if we're talking about this in product development context, then one question I have is where and how should a product team stop to achieve the satisfactory, at least satisfactory completeness of the causal theory? I have two more. I'm sorry, you could pick one if at least. I don't want to take the whole time.
Okay.
And the second one was, identifying causality in social systems is actually really difficult. And, we have to do randomized controlled trials, and even those are problematic in terms of generalizations and so on. And one issue when it comes to collaborative theorizing is that many people hang on to their intuitive understandings, which not necessarily correspond to the real causality. And one question I have is that while this collaborative theorizing is happening, how do we actually ensure that we reach to a true causal theory instead of, getting carried away by whether some people's, way of speaking is more persuasive, or some things sound more attractive or interesting or not. And I think actually I'll just skip the last one. It's too abstract. So I'd be happy to hear your opinion about any of these questions.
Yeah, those are exactly the right questions. Those are like all the hard questions, right?
Exactly.
Right. And so so the first one is a really good one, right? Like, because there's never, you're not seeking, the correct causal theory or the correct dynamic hypothesis, like, because no one even knows what that is, right? What the correct one, what the true one is. But it's a good question about determining where to stop, right? And I think the initial, this is what our follow-up work is about actually kind of testing the constraints within product development, right? Because there are, time limits for doing a cycle. And so what we're focusing on is kind of understanding, if you think about it, we do like design sprints, right, as a part of product development. And a design sprint could go on forever if you wanted it to, right? But we found ways to kind of constrain that and say, hey, we're going to spend 2 days to get our kind of best understanding of what the feature capabilities are and put our best minds together. And so I think this is like a similar approach, and I think it will be, if you think about how things are done now, we're not doing this step at all, right? And so even if we start to introduce it and we're only going to spend 2 days, and we know that we're not going to end up with the perfect dynamic hypothesis, but we will at least learn some things about things that we weren't considering that we might be able to consider. We will have a better basis for planning and thinking about our interventions, and that'll be the limits of what we get out of it, right? And so I think this is only going to come from like practical approaches and piloting within real environments where you have to deal with like the real pressures of like developing something, making go, no go decisions. I don't think there'll be one right answer. It'll depend on the context. And then the second one is also like, this is not as you say, the way that you kind of set up these environments for participation, there's all kinds of dynamics that influence what ends up in these diagrams. You're dealing with humans. They have their preconceived ideas. Some people are more persuasive than others. That's going to influence the, I guess you can say the quality and the reliability of what you produce. And this is why there's this step where you do this qualitative step, but you actually, this is where the simulation becomes important, and where it becomes important to actually add data and observations, historical data, so you can actually raise your confidence that at least this structure can generate historical data that we've actually observed in the past to raise your confidence. You're still not gonna, this concept of true, I think is kind of like a red herring, right? Because even the data that you're using to validate this, that came from some people making some specific choices to even measure specific things. And those choices were influenced by some causal theory that was implicit. And so even those observed data, don't represent truth. They represent some aspects of reality that some people chose to measure. in a particular way. But just, but you're totally agree with your point. I just think the key thing we have to do is just kind of be careful about being about this concept of truth, right? Because even if people have these theories, their intuition that is that may not be correct or that may be biased, they are real factors that influence what happens in society. So just the fact that we've made them explicit doesn't mean we agree with them or that they're true, but they are real because people are making decisions based on that, and they're generating social reality based on those perspectives. So one thing, you just want to have those explicit, even if you never agree with them, right? Even if no one would ever say they were true. Just that step of making them explicit and acknowledging that they are real, not necessarily true. But if you don't understand, if you don't know that they exist, you can't do anything to mitigate their impacts. Does that answer? Hopefully that answers the question.
That was great. Thank you very much. Yeah,
Okay.
thanks a lot.
Thanks again for asking the questions, for just being so brave to do it. Fantastic. I have another question here from the community again. So the question was, it's also more hands-on regarding practical ideas models. From a downstream machine learning perspective, how would one use such system dynamics inspired graphs on downstream data collection and utilization in ML models? Is there perhaps a tested workflow for doing this?
Can you say that? Can you read that back one more time?
Yeah, for the last part or the whole thing?
The whole thing, if you don't mind, sorry.
No problem. From a downstream ML perspective, how would one use such system dynamics inspired graphs on downstream data collection and utilization in ML models? Is there perhaps a tested workflow for doing this?
Yeah, I mean, so for the first part, the idea is that the way that this would be used by the downstream data collection process is to even influence what data should be collected. Because oftentimes we start with the data that exists. There are data sets out there, let's go find them, right? That might be able to help us with this area. And the idea here is to there are some factors that we may not even have data about, but we can determine how critical it is to the dynamics of the system that we're trying to intervene on. And then we might say, hey, guess what? Either we can't do this project or shouldn't do this project because we can't acquire data about that, or we should make one of the critical path items to actually start measuring this data so that it exists so we can factor it in. So that's one of the main ways that I see this impacting kind of this data selection component. Because right now, as I say, we kind of start with the data we have as opposed to understanding what data we need in order to actually understand the structure that we're trying to intervene on with our ML system and our product. Now, so my intuition is that the other way that this kind of impacts further downstream is that this, eventually you get to the point you want to test the performance of an algorithm or a system. And typically you want to understand what your test criteria are going to be in the early stages when you're defining your requirements, right? It's too late to wait after the fact. So this problem understanding work is really it's really kind of requirements gathering and understanding. And so it's at this point where you should be determining what should we be testing for? What should we be worried about? What risks should we be identifying so we can make sure that we test for them during the downstream stages. When you're trying to come up with a test in the middle, that's not informed by what the actual requirements were, what the actual problems are, then your tests are going to be less effective.
Mm-hmm. Thanks a lot. Just so since we moved ahead with the time, I have two questions just closing the round today. One thing is just a side question. OpenAI has released GPT-3. And did you have some time, or did you ever test it a little bit, or if there's some bias in there as well regarding how to supplement text or so?
Yeah, I mean, so natural language processing is not my expertise.
Okay, happy.
Yeah. So I wouldn't be able to comment on that very well. Although I can say in general, just what we were talking about before. GPT is still driven by you know, data, right? And so we just have to remember that, you know, no matter what algorithm you come up with, it's driven by observations and data. It's going to interact with observations and data that come from society. And those are where the biases exist, right? Those are where the biases originate.
Which brings me basically to my closing questions, which is more like asking you for a statement. You probably know the European GDPR law, GDPR, the privacy law, right?
Yeah.
And
I know about it. I wouldn't say I know it in detail. I think it's pretty big.
yeah, it's pretty big, and you don't need to know the details, but I would point on one detail, which is, so in case, say, I apply for a loan, for example, and I think the process was not justified because the loan was not accepted. My request was not accepted. I was refused here, and actually, based on the GDPR law, you can complain about that. You can say, I would like a human being to have a look at it and test it because I think that was not justified. So this is good in the process. It brings me back to my question, because I'm more and more I think about it, more I listen to you, I just thought, can any kind of machine learning algorithm ever be balanced and just in the sense that will we ever feel that we are treated well by such systems? Is it possible at all?
I mean, so I would just kind of flip the question around and ask, like, do you think it is possible to kind of feel that way with human systems, right? So you're interacting with the bank. Let's assume that you have no idea that there's any algorithms involved at all. Like, you know, can you get to the point where you kind of feel like that system, that institution is treating you fairly, right? And what does that feel like, and what does that mean to you? Like, how do you get that? How does your interaction with them give you that feeling? And then just to say the aspiration of ethical AI or AI is to get to the point where you can have this equivalent feeling that you're dealing with, you know, a system where you can have the same kind of interaction and feeling that you would with like a human system. So some people may say, I interact with a human system and I would never feel like it's treating me, you know, just as well, right? So it all depends on like your perspective, what your experience is in the world, what your context is. It's context dependent, right? So, and I think that's going to be true for AI systems, right? It's going to be context dependent on whether or not you would ever get that kind of feeling of trust.
Yeah, thanks a lot, Donald, again for the presentation today. I think it was pretty exciting, pretty interesting. I can only say that was awesome. Thanks also, Andrea, for joining me and just not leaving me as the man who's guiding all the people all the time, but to have me, a woman on my side, which was also asking the questions. But we were more diverse in that sense as well. Thanks for both of you. Thanks for everyone who joined us today. As always, I can only tell we have been recording that session, and we will make it available on YouTube, of course, in the AI Suisse channel. And once I get the links from Donald about the part which can be published or linked to, I'm going to link it in the video as well. So thanks again for joining us, and thanks guys for being just part of the panel today. It was just fantastic.
Thanks, folks.
Thank you.
Bye-bye.
Bye-bye.